Hello, welcome everyone to SurrealDB stream number 32. Great to have you all with us today. Let us know in the comments, in the chat, if you're on YouTube or LinkedIn or X. Let us know where you are, where you're calling in from, where you're listening in from. And yeah, if you've got any questions as well, put them in your comments in your chat and we'll try to answer them as well. I'm joined here today by Martin, and Martin's going to be demoing some awesome stuff to do with AI, LangChain, autonomous agents, and the world which sits between vectors and graphs, and we'll be talking about how multimodal data and how multimodal querying can be used to improve everything, to be honest, in our opinion. But you know, the context, the reasoning, and the memory for autonomous applications, autonomous agents, AI generally. So, Martin, great to have you with us. Before we get going, I think it's probably important to start with why, the big question, which is how are people building applications today in the world of AI? Typically, they're using multiple data stores. They're combining these tools together with ETL tools, glue code, an application layer. How are people building right now in the modern applications that we're seeing being built in the AI space? Hang on a sec, Martin, I can't hear you.
There you go. Can you hear me now?
There you go. I can hear you now. Brilliant.
Cool. Yeah, so I have a couple of demos, examples, screenshots here. First, yeah, I think you're watching a graph, right? Let me just maybe take one step back to add some context. This is just a demo of a chatbot that basically reads your WhatsApp groups and then helps you remember some stuff.
Martin, before we jump into that, let's touch on kind of the traditional way that people are building their AI applications today. So if you're not using SurrealDB, the chances are you've got a vector database, a graph database in some contexts. Sometimes people are just using RAG, so they're just using vector, or they're using something like Postgres with PG vector. What's the typical kind of infrastructure or tool set that people are using right now?
Okay, so usually everything starts by you having a database, right? So you store your knowledge base plus some frameworks. For example, let's say LangChain, right? So LangChain has multiple of components. There are components that allow you to ingest data, for example, ingest chat from WhatsApp, or ingest PDF files, or ingest just documents from Google search, or anything basically, right? So you have components for ingesting or loading documents, components then for storing those documents. There are vector stores, the most common now, but also you have graph stores. And then you have also components for the chat, like have the LLM chat with your agents and with the users and so on. So basically the architecture looks like usually a sequence of steps where you have ingestion happening at the beginning and then just queries that go into your database. You have similarity search, for example, when you want to build the context to have the LLM answer based on your knowledge. So you usually do similarity search, which is powered by vector search. So people usually have a vector store where they have previously ingested documents, and then using similarity search, they get some of the context. There are some other advanced techniques like graph RAG, where you have this similarity search or semantic search together with graph queries to make sure that the context you're building for the LLM is not including just similar things that are actually not related, but are still similar. So when you add graph into the mix with similarity search, then you are able to actually create a context that makes more sense. It's more semantically correct.
So really, summarizing all of that, it's complex, right? Depending on how much you want to, how accurate you want to have the context, or how good you want the reasoning to be in the AI agent or the AI application or the client, depends on how much you're willing to kind of invest in different parts of the infrastructure, whether you just use vector and RAG and semantic similarity search, or whether you also then combine graph with your documents, with that vector search, with other types of search like full text search to give you better context, better search, better matching, better reasoning. And then you've got to tie all those things together.
Correct. Yeah, exactly. And also you can have more like asynchronous processes building the graph and building the vector store. So you're still making it even more complex, so that you represent your knowledge in a better way in a graph and a vector store. To then, when there is a query at a user, then everything is almost like fresh and ready in a graph format and easy to retrieve.
Awesome. So before we dive into why multi-model databases or something like SurrealDB can benefit this, let's touch on what we're going to talk about today. So we're going to demo how you might do something like LangChain sitting on top of SurrealDB. So LangChain being a framework which enables you to work better with in an agent-like way, but using specifically vector stores. So a vector store to store the vectors, the tokens, and therefore in order to perform similarity search or semantic search on those on that data, and therefore to provide context to a chat. And then we're going to go a step further and say, actually, you can do without LangChain. You can actually go and utilize SurrealDB more effectively and combine different models together to give better context, better relevance, and we'll demo that as well. So how does SurrealDB play in that big spaghetti mess that you described of all these incredible tools that you can combine together to make your AI application incredibly useful and incredibly accurate? But to do that, it is a mess. How does SurrealDB play in that space, and how does it simplify things?
Cool. Yeah, so if you can see my screen, I have a very simple RAG diagram.
Yeah.
Where you can see that at the bottom we have two LangChain components that we created to integrate LangChain with SurrealDB. So we have the SurrealDB vector store, which is a LangChain component, and the SurrealDB graph as well. Both are components that actually are querying the same database, since we are multimodal. And here you can see that whenever there's a question from the user, there's a similarity search happening that hits the vector store. And on the right-hand side, we are also inferring keywords with the help of LLMs to then generate a graph query that will hit the graph, right? Then you can combine both results to generate an answer. So making sure that the LLM will get maybe some information from the similarity search and some information from a graph search, and together build like a summary of the answer. So this way you can basically see that you only need one database and still be able to use the vector store and the graph store from LangChain.
Awesome. Now, what is the different? So I think our users might ask, kind of, what is the benefit of storing things in vector, and therefore what type of information do we store in vector, and what is the benefit of storing some information in graph, and as a result, what is the type of data that is typically stored in the graph?
Yeah, so I would say it's basically being creative to have more accuracy and less latency, which is also like better costs. Because if latency was not an issue and costs were not an issue, then you will have kind of like basically brute force querying your knowledge graph. But people have found out that a combination of vector and graph gives you more accuracy and is also faster. There are some papers, for example, about LightRag, which is more complex than this. This is a very simplified LightRag architecture, where you invest some time inferring keywords and generating a graph based on things you inferred that are not exactly explicit on your knowledge base. So you basically build a graph so that whenever you want to retrieve information, it's just almost ready for you to query. So it's for latency, for accuracy, for costs, and about just getting creative with how to solve those three, let's call them bottlenecks in your specific use case. And embeddings, for example, work great. Like if I move forward and show you, for example, some raw data, and this is just a made-up conversation, right? So embeddings will help you figure out which chats are maybe similar to the question you're answering. But from a chat like this, there's more information besides what you can just see at clear sight. For example, you could take the dates and create a graph with the dates. Like, let's connect a conversation with a specific month in time. Or you can create a graph also using the names of the people. So you can relate what Liam said on a specific month or week, depending on how granular you want to go. So you can basically generate a graph from information that's exactly not there explicitly, but you can just find those relationships. And what people do is that they actually use LLMs to figure out those relationships, which here are very clear. Like we have dates, we have people, we have chats, but there's also like keywords and things you can still construct a graph out of.
Yeah, so it's about combining all different types of methodologies, each of which has benefits, right? So I think the world has jumped onto vector search and RAG, but now we're seeing people come back a step and actually saying, that works to an extent, but it hits a limit, and actually combining that with full text search, so traditional keyword matching or keyword search or term search can actually improve my search generally. And I think graph is the same, right? It's basically able to say, I want to explicitly define relationships where I know that there is a match or a similarity or a relation of some form in order to improve the context that my AI or my application can get. So that brings us then onto the topic of what we're going to go on to next, which is LangChain, and you were talking about the example application. So you've got some chats there, example chats, like say from WhatsApp or something like that. Let's jump into LangChain and let's just do a quick demo before we move on to how you can combine these things together, of what you can do just with vectors.
Yeah, sure. So here I have another screenshot of one previous run of this example. Oh, sorry. There you go. So here, for example, this is showing like the internals, like the diagram I have before. So for example, if I query what book am I reading, you can see that we can do like a similarity search. We get some scores like how similar the query is to the chat that was found. And here you can also see that the LLM is inferring keywords like book and reading, and then using those keywords in a graph query so that we can mix the results from vector and the results from this graph. Then the LLM is basically 100% sure that I am reading this book, because both the vector search and the graph search like read basically gave the same response.
Yeah, so that's using both there. Can we jump into there you go. Yeah, so let's jump into actually how it's working under the hood, or having it running. Is that possible?
Yeah, so I have some snippets here that maybe give you like a quick overview, and so people interested in how this looks under the hood.
Yeah.
So as you can see, for example, there are WhatsApp loaders and Instagram chat loaders. Those are provided by LangChain. So there's like the building blocks you can mix and match. This is for the ingestion part of the RAG architecture. Here, for example, is where you can interact with an LLM and give the LLM some instructions, like please infer some keywords out of this query. The prompts look like this. So it's a lot about prompt engineering. So you can give your agent like a specific role and the goal, these keywords that represent the main themes and topics in the messages. So this is basically to generate a graph based on keywords, so that you have a graph based on keywords related to chats. And there is some. Yep, go ahead.
I was going to say, so really, we didn't touch on the benefit of having it in a single store, because with LangChain you've got many different implementations you can interact with. You can interact with vector DBs, you can interact with full text search DBs. You can store your data in many different places, and that's where something like SurrealDB can actually benefit the user a lot, because you can actually store your full content of your document or your metadata or your chat or whatever it is about, but alongside that you can then store the tokenized vector representation, which is produced by an embedding from either a local LLM or a remote LLM API like ChatGPT. You can store that together, and then using that you can add a full text search index to the document, the content itself. You can add a vector search index to the tokenized vector representation. You could build relationships up between different chats, different people, different users, dates. You could filter based on date as well, without having to actually just implement that on different storage engines or different database engines, and having that in a single query. That's really where we're going with this, isn't it?
Yeah, I have here an example, a simple example of how this looks on the database for this same chat example. So here, for example, I have a documents table. You see only 4 documents because instead of storing one single chat as a document, you actually want to chunkify them, so that you have a chunk that contains, like, hopefully the whole conversation, which is maybe around one single topic. So in this case, for example, I just used the dates. So every time there is like a 3-hour pause, I just cut the chunk, and I upload the chunk. So here you can see, for example, if I minimize this or scroll down, here we can see the vector embeddings, right? So you can clearly see this is a good example of multimodal, because you have a document that contains the vector embedding, but also at the top you have metadata, which is like just a JSON object. This is just the metadata where I have the inferred keywords, but I'm also using these keywords on the other side to generate a graph.
So in a single query, you're then now able to filter on those fields, those columns. You're able to assign an index, a traditional index, a full text search index, and then also an index on the vector search fields, so that the vectors, and then actually able to combine those queries together.
Correct. Yeah. So here, for example, these blue dots represent documents, which are the same table I was just showing. But here you can just run a graph query and see the same documents linked to the keywords, right? So for example, these is a food keyword assigned to this specific chat where we may have been talking about our favorite dishes, right?
Yeah, so immediately you can start seeing or visualizing, because the application doesn't need to do this itself, but you can start visualizing those patterns and the relationships between that data.
I have another example. This is a bigger one. Same example with some documents, but in this case, each document has a category, but also a list of tags. So this is very interesting because if you query for categories, you can see that it's very clustered, right? There is just a few categories linked to a lot of information. But if you do the opposite and select by tags, you'll see that it's a completely different graph. It's because there's a ton of tags and a ton of documents. So there's very, very connected graph in a way, right? So visualizing the data like this helps you understand, like, okay, maybe for specific cases, I would use tags to get maybe a more richer context. And for other cases, I may want to filter down by categories to make sure that the context is basically specific about a specific use case, maybe related to a specific category and so on.
Yeah, that's brilliant. We've got just before we carry on, we've got a question here. First of all, Alan, welcome. Great to have you with us. Just Dot, great to have you with us as well. And Sumit has got a question about, can we clarify how we have generated the vectors?
Yeah. So to generate the vectors, usually you use an embedding model. So in my particular case, I am running Olama locally. You could also use Hugging Face models. You can use OpenAI, Claude, etc. So usually you have LLM models that are very big, good for answering or generating summaries. But there are also other types of models that are just much smaller and tweaked and optimized just to generate embeddings, like semantic embeddings out of documents. Also depends on your use case. For example, if you want to embed short phrases, you would choose a specific model. But if you want to embed maybe bigger text like a chat, then you can choose another model. Also, there are models that are fine-tuned to specific industries, for example. And so it can get very complex depending on how much you are wanting to spend on tweaking for maybe higher accuracy, lower latency. So usually, in my case, I run Olama locally, and I'm using one of the all mini embedding models specifically for embeddings. And
but you don't have to, right? You can call out to an API. You could use, as you say, a local GPU. You could run these. They're relatively lightweight as well, so you can run them on the CPU as well without a GPU, right? To generate those embeddings. It's not optimal, but it can be done, can't it?
Yeah, exactly. And it depends also on the framework you're building this on top of, right? If you're on LangChain, then you would use the Olama component, for example, or the Claude component. So there's a ton available.
Awesome. So we've now touched on why. This is such a big topic, so we can only really touch on it in a small stream like this. But we've touched on why keeping documents, graph edges, vector representations, and, as I say, the content of the document itself, so those fields and those columns together in a single place, enables us to drive better context, reasoning, and memory out of our data. It enables us to see better patterns, and it enables us to write better queries because we can combine those things together. So I think the next step is, can we make do without LangChain? Can we go a step beyond that and go kind of fully SurrealDB native, vanilla as it were, and combine whatever we can combine together. So let's say vector search, graph, potentially even a full text search, index and query, whatever we can combine in order to get the best context out of the data without using a framework on top. How's that sound?
Yeah, that's the beauty of SurrealDB. You can do a lot, because usually frameworks assume that you have different stores. So the abstraction layers that these frameworks build are assuming that you have a vector store, and then that you have a key value store that's a different database, and a graph component that they assume it's a different one. But with SurrealDB, usually you can like skip that abstraction layer and just query directly to SurrealDB if you're using SurrealDB to have everything, like the vector store, the graph. You can store documents, relationships, everything, even like the short-term memory of your agents, like the chat messages, the context. You can basically store everything and mix everything together, right? So you can store whatever you store, you can add the embeddings, for example, and at the same time relate that to the graph. So you can even add your chat memory to the graph you're building if the use cases make sense.
Awesome. So this might be a big ask. Can we bring up a demo of the vanilla, no framework functionality and querying being run on SurrealDB?
Sure. Yeah. So the same this. Let me sorry to try to bring this here. There you go. So here, this is my terminal. Maybe I'm going to make this a bit bigger. So this is actually just a test with vanilla, what I call vanilla graph rack, like using Python almost directly with SurrealDB and Pydantic on Python.
So give us a real short or quick summary of the kind of the steps of how it works. So it's written in Python. How does data get into the database? What formats are we storing in it? And then how do we query it?
Cool. So to give some context, I started this by trying to query my bookmarks. I'm a heavy user of Firefox bookmarks. So I have a ton of bookmarks, and I have tags and folders. So there's a hierarchical structure into my bookmarks. So I created a script that parses the bookmarks in JSON format that you can export directly from Firefox, and then I ingest those bookmarks. So they only have like a name, an URL, and tags, and the structure, like the folder structure, right? So with that, it's enough to build like a graph based on the tags and the structure. But besides that, I'm adding the vector embeddings as well. So I'm storing all of my bookmarks with the embedding and with some infer attributes. So if I can
and what are the inferred attributes?
So this is a nice trick. Let me see if I have here. Yeah, this may be a bit messy, but let's see. Yeah, maybe.
Well,
maybe not.
If you're joining us from YouTube, I'm not sure the X comments come through, but if you're joining us from YouTube or LinkedIn, and you've got questions about what we're demoing today, or any other questions around the topic, then put it in the comments, and we'll try and answer it. Sorry, Martin.
Yeah, no worries. I'm looking for a good example. Yeah, here it is. So here we can see a document, which is a bookmark coming from the exported JSON from Firefox, and I have a JSON about inferred attributes. So this bit here are attributes inferred by the LLM. So this is information that was not on the original data, right? Although I have tags and hierarchical structure on the JSON, in this case, I'm inferring the tags, so basically generating them.
So you're generating tags, but you're generating them not into a tokenized format. You're generating them into an actual natural language format as well.
Yeah. So the LLM, based on the description of the bookmark, it generates the tags, and then it uses those tags to create the graph relationships. So when I ingest this bookmark, I store in the database the bookmark itself as a document, which is this record you're seeing. But I also then create a set sh document and an auto suggestions document, and then relate those with this specific bookmark. So I basically generating a graph out of tags that were not part of my original data, right? But this is very common in LiteRag, for example, that you generate a graph based on inferred information that was not particularly originally present in the raw data. And the way this is inferred is because it's a nice trick with Pydantic, because basically I define the Pydantic structure and I give the Pydantic structure to the LLM so that the LLM knows what's information I want to infer. If that makes sense. If you know awesome. Pydantic, it will resonate with you.
Yeah, I mean there are so many frameworks that you can use now in this day and age, aren't there? You know, you've got LangChain on the agent side, you've got Agno, Crew AI, Camel AI, Pydantic AI, LiteRag. So we're building a lot of the integrations across all these tools for SurrealDB. I think the most important aspect is you don't have to use SurrealDB alongside another data store. You can use SurrealDB as the only data store alongside these integrations. So we've recently done LangChain and Agno and, correct me if I'm wrong, Martin, a Camel AI, right? One.
Correct.
And we've got more coming soon. So we're working hard on integrations with all of your favorite tools. So give us a shout out if you want us to work on a specific tool. We're always keen to hear. There's so many tools out there. We're always keen to hear the new ones or the ones that our users want us to integrate with. But ultimately, our aim is to have SurrealDB fitting in the way that you need as a developer or as an organization with the tools that you use. So whichever framework that is, but you don't have to then worry about different data stores with different contexts, with ETL code, with glue code, with data transformation, with queries that have to span different stores and don't have that context, don't have that relevance, and don't have the performance across those different stores. So that is what SurrealDB is solving. Martin, let's carry on jumping in and look at how this can be used without a framework.
Yeah. So I found here part of the code where I'm defining the models. And as you can see, so I'm defining in Python what the inferred attributes I want. So basically, I'm defining a base model that's saying I need a brand, which is optional. I need category to be inferred, which is one of these specific options. And I also want a list of tags that is, it's open-ended, right? So I just give the schema of this base model to the LLM, and then the LLM creates the brand, the category, and the tags. And during ingestion, I just make sure that I create a graph based on the relationships that the LLM found using this specific structure. And so by using Pydantic and a base model like this, I'm basically enforcing a structure to the data that LLM is generated, which usually is a pain point, right? That LLMs can just generate anything, and then your graph becomes very like random. You have maybe a ton of categories generated. Worst case scenario, if you're not careful enough, you get electronic and electronics, lowercase, uppercase. So the more structure you add early on, the better. Also, you should deduplicate keywords, and there's like many ways you can do that so that whatever you get inferred by LLM is like clean enough, right?
This brings us onto a whole new topic for another stream in the future, which is how to actually work with LLMs in the best possible way when you're using SurrealDB and these frameworks. But actually, how do you get the most out of it? So obviously, this stream has talked about SurrealDB and the benefits it brings when you're working with frameworks or autonomous applications or autonomous agents or AI generally. But actually, there's a whole new topic around how do you work with the prompts better? How do you work with the processes? How do you work with the data cleansing? I guess that's a topic for another day, right?
Yes, and especially prompt engineering, for example, that's a big thing. It's independent of the framework you use. Prompt engineering is huge. And that's also one of the beauties of using SurrealDB directly. That usually I store also my own analytics. So during ingestion or during querying, I store some information in the database to then eventually run queries to calculate like my performance. So in this case, for example, I'm just using our like document model, for example, to store analytics. And I basically store like prompts that generated valid answers, and I give that a score. Right?
So you're constantly able to reevaluate the performance of the agent or the application or effectively the LLM long term, right?
Exactly. So here, for example, you can see a cool query that basically I'm counting bad scores and correct scores. This is Boolean, right? If the LLM was able to generate a good query, for example, or not. And then I can see that at the moment, this demo is generating 95% correct inference. So basically, if I change the prompt and I do the ingestion or the querying again, I come back here, rerun this, and see if my new prompts just give me like a better or worse score. So without the need of actually like a different solution to actually do the prompt engineering in a structured way. And this isn't the same database, right? So everything you need to store somewhere, then just drop that into
you can store
one of the schemas.
You can store the data, you can store the vector similarity tokens, you can store the graph relationships, you can perform the full text search, you can then go and store the logs, the analytics, the metrics, you can self-reason about the data, you can understand the performance long term. What wouldn't you store in here?
Yeah, exactly. And one other of the latest features I've been trying is also coming back with the question, like, how do I generate embeddings? And one nice thing we can do is if you mix and match some of the unique SurrealDB features, you can create very, very useful workflows. For example, we have event triggers. So we can trigger an event whenever there is a new document in a specific table. So imagine adding a document without the embedding, right? So you can basically trigger the generation of the embedding just by inserting the document.
Asynchronously and dynamically behind the scenes.
Exactly, awesome. Right. So, and then you can also, on those triggers, you can call an external API if you enable like network like outbound network from within the database. So you can basically just insert a new document into the database that will trigger an event, and then the event will call an external API that could be like, like Cloud API, or your own microservices running your own embedding models. And then basically you are going out of the database just to ask for the embedding, the vector embedding, and then you store the vector embedding in that new document, which is very powerful because it simplifies the whole architecture. You don't have to generate embeddings everywhere. You just make sure that the database is generating the embeddings for yourself.
And it's flexible as well, though, right? You can choose how you want to store those vectors. If you want to store them in an embedded way or separate documents, or maybe you might want to split up your vectors into multiple little chunks. You can choose as a developer how you do that or what you do with it.
Yeah, exactly. And since during the ingestion and the querying, you need to make sure that you use the same embedding model. One thing you can do is use, like, you define a namespace, but then you can have different databases. And so usually I create different databases to try different embedding models. And then it's very, very simple to set that up because the same embedding model using during ingestion is the same embedding model you're going to use during querying. And if you create a new database with a different event trigger calling a different API, then you have a new database using a different model, and then it's very easy to compare both, like basically to create your own benchmarks.
Clever, very clever. We're going to jump into some questions and some comments from the audience. So Flutter, great to have you here with us and discovering SurrealDB. We're glad you like it so far. We're working on some amazing stuff, right? Obviously 3.0 in the pipeline, a lot of focus around performance, connectivity and stability as well, and some other incredible integrations that I mentioned earlier. But I think also we've got some great stuff that we're working on, which we can't talk about just yet, but that's in the pipeline, and we'll be announcing it soon. So right now you've got SurrealDB, and every way that you can interact with it, integrations with the frameworks. We've got some awesome stuff that we're working on as well. Utkarsh, thank you. We got this, hopefully. So, Nekmerton, great to have you with us. Tobie Martin, are embeddings stored in memory at the Tykov cluster? It's a good question. So embeddings are stored on the disk. So they're stored in storage. The vector search index is something that is effectively depends on what type of index you have. So HNSW is typically an in-memory index structure. And HNSW indexes, when running in a distributed context of SurrealDB, are stored on the storage engine, but then are replicated to each of the compute nodes. Now, what we're working on at the moment, there's a lot of work being done on this at the moment, is being able to shard that HNSW index across the cluster. So right now, you can run a 10-node SurrealDB cluster, and you can scale out your reads across those HNSW indexes across the different compute nodes. And if a change is made on one node, those changes will be visible in the other nodes. The issue right now is those HNSW indexes have to fit within the total memory of each of those compute nodes. What we're working on is the ability to shard that HNSW index, or those HNSW indexes, across those nodes, so that if you've got a 1 terabyte HNSW index capacity in total, let's say, across your entire database, you don't have to have a 1 terabyte machine memory in order to execute that and query that. So that's what we're working on. As I say, most cases running that in memory is not an issue, but sharding, especially when you're dealing with terabytes or petabytes of data of the HNSW index, is something that we're looking to have in very soon. Sumit, great to hear that would be interesting for you. We'll definitely get a stream on the horizon for kind of how to work with the LLM. There are so many different ways of doing this, as you probably know from the interwebs at the moment. Things are changing all the time. Different ways of working, different tools, different frameworks, different recommendations, different research. So But yeah, we'll definitely do a stream on that, how to work with the LLM both locally, remotely. We've also got some great tools and functionality coming out which will improve how you work with LLMs generally as a developer, and how you build the applications on top of those processes and frameworks. So we can't wait to share that with you soon. But yeah, definitely in the meantime, we'll get a stream set up for working with LLM, working with prompt engineering, working with data cleansing, and tying up that kind of whole pipeline together with SurrealDB. Make Stuff, great to have you with us as well. So Make Stuff been using SurrealDB for multi-agent systems. It's been amazing. That's great to hear. I'm using Valkey for cache and messaging, PubSub. Is there a method to do this in Surreal instead? You know what? This is not the first time we've been asked about this, definitely. So in terms of caching, we're working on, and coming in 3.0, we're working on a big improvement to the in-memory storage engine so that you can effectively use SurrealDB in place of Redis or something like that for caching of keys to values or result sets or whatever you want to cache effectively. You can have that running in multiple different nodes in the same way that you might have Redis running. PubSub is a different matter. So PubSub, we're building in some functionality. I won't talk about it too much today because it's a whole different topic. But that functionality will enable you to link and integrate with different tools. So although SurrealDB is not itself a PubSub platform, and that's probably not the way you should use SurrealDB, we do have clients and customers and developers and users using us in that way because of the ability to, as Martin said earlier, define events which can call HTTP endpoints asynchronously behind the scenes and can perform work when events change or when data changes in the system. So we're working on tooling that will improve how you integrate and link with other platforms. So that's probably one that we'll come back to a little bit later this year, because I think we'll have some exciting stuff that should make that easier for you. But generally speaking, yeah, 3.0 is going to be is going to have some exciting improvements around caching, performance, in-memory storage, and functionality for integrating with other tools. So we'll update you when we've got some more news on that side. Any timeline for that? I mean, remind me of your question. Oh, the Tobie. Yeah, that's being worked on at the moment. So the aim is to get that out into the 3.0 release, and we don't have an exact time for that, but not long now. And final question now before we head off. So Nekmutten, is there any harm doing multiple table full text? So a semantic search on multiple tables in a single query. Martin, what do you think about that? So what about a semantic search on multiple tables in a single query? It's technically possible. What do you think?
Yeah, there should be no problem. I know that we have an OR operator to do hybrid search, and they're actually doing some POCs on that. So there's a couple of improvements that I think were merged, if not, I'm not mistaken, like last week already. But yeah, so
yeah,
completely possible.
Yeah, exactly. So just to dive in a little bit more on what Martin just said. So we've actually got a new function, a new search function for performing a hybrid full text search and semantic search query. And that completely improves the accuracy, the relevance, and the performance of a full text search query. We've got users who specifically requested that functionality, and so that'll be in 3.0. Really exciting news on that side. As Martin said, that was emerged either this week or last week. So really new stuff, but really relevant in the AI space right now. Being able to perform that on multiple tables in a single query, absolutely possible. You don't have to use joins. You just specify multiple tables. The query planner will work out which indexes to use behind the scenes. Obviously, you do have to define those indexes, otherwise it's just a brute force search. But yeah, absolutely. Hybrid search across multiple tables, that's what SurrealDB is designed for. Peter, great to have you with us. Will V3 be far different from V2? Any refactoring needed? Using Axum and SurrealDB V2 right now. We want to make it as smooth as possible, but we are really kind of re-engineering the entire database core to make it more performant, more stable, improving how SDKs and clients communicate with the database as well. There will be some breaking changes around futures and Lambda functions as well, and storing those in the database. We're trying to make SurrealQL easier to reason with, because that kind of leads to better performance and it leads to better developer experience long term. So we're going to be introducing a couple of new pieces of functionality. One of those is called a computed field, and we're going to be removing futures. So that's one of the biggest changes there is, other than kind of internal refactors and how the data is stored and how the data is modified in the core engine as it goes through. But we want to make that process as smooth as possible. That said, there are some breaking changes, yeah, absolutely. But V3 is going to be a massive improvement on version 2, and it's going to be worth it, especially with some of the stuff we're launching and bringing into version 3. So as I say, we'll know more nearer the time, and we want to make that process as smooth as possible, but there will be a few changes that will need to be made in the application side, yeah. One more question here from Sumit. Is it easy to migrate the database from one backend to other? Like, I'm now using RocksDB, but later want to move it to FoundationDB. I want to know how the process is smooth. That's always a tricky one, because they do handle data differently. So right now you have to export with SurrealQL and import with SurrealQL, which doesn't necessarily work terribly well when you've got large amounts of data. We're looking at improving this so that you can do this in a binary way, which means you're not going through the parser or through the executor. But also, there are limitations with FoundationDB. So just as a side point to your question, definitely chat to us on Discord, if you're on our Discord, about using FoundationDB. There are limitations to what FoundationDB can do. There's a limit on the transaction time of 5 seconds, the amount of data that can be modified or read in a transaction as well. So bear in mind that FoundationDB does have limitations. It works. We've got users using it in certain situations, but you have to bear in mind those limitations. But those limitations bring better performance in some cases. So there are trade-offs. We want to make that process smoother. Obviously, in the cloud, going from a single node to multi-node is something we want to make as smooth as possible as well. So that's something we're working on improving. But yeah, generally speaking, right now you have to export and import your data, and we'll look to improve that process going forward. So that's it from the questions from the community. Martin, I've got one kind of final set of questions, which is, and this is going to have to introduce a new stream in the future because we haven't had time today, but live queries, right? A lot of our users use live queries for real-time notifications from data that changes in the database. Really quick summary. How is that going to be useful for AI agents or autonomous applications in the future? How is change feeds or the changing of data with notifications going to be useful to improve the apps that people are building?
Yeah, if you ask me, that opens up a lot of possibilities, right? Because, for example, in low latency scenarios, where you don't want to be polling for something to happen to react. For example, if you are working with memory compression or inferring data or stuff like that, then you can use live queries to subscribe to new records, for example, and then basically reacting to that instead of polling, right? So basically it creates a socket connection between your tables and whatever process you're running. You can use that creatively.
So we'll pause that because we're going to have to do a new stream on that topic in the future. But what I would say is, if you look at the MCP protocol, so the Model Context Protocol, the new latest protocol specification for that touches on or has moved towards HTTP streaming, so that the agent or the client can then get better information pushed to it as opposed to constantly checking or pulling for information. So that's the way that agents and clients and AI applications are going. We'll push that forward to a different stream in the future. We'll also add to our stream timeline one about LLMs, data cleansing, and prompt writing and prompt engineering as well. And just to say, look, thank you for the questions. Thanks for joining us today. It's a massive topic, so we didn't get to touch on everything. Hopefully that spurred your thoughts in certain directions about how SurrealDB can better be used as a single tool, but to combine different methods of querying and different data types together to bring out better context, better reasoning, better memory, and generally better access to your data. If you've got questions, definitely join our Discord. If you haven't tried out our LangChain integration or Agno integration or Camel and other things like that, then jump into our docs. And always open to comments or pull requests or ideas or anything like that. So that's it for the stream today. Thank you for joining us. Hope you have a great day, evening or morning, wherever you are in the world, and we'll see you on a stream in the future. Thanks, everyone. Take care.
Thank you.